In this video, we're going to continue our work on section 2.3, and we're going to look at some examples. So one thing that I want to emphasize here is in this previous box where we had this slope of tangent line given as a limit, this limit is often referred to as the limit definition of the derivative. Turns out there are a few different ways to define the derivative, but this is the limit definition, and this is the primary definition that we will be seeing in this class. So in these notes, we are going to be computing derivatives using this limit definition. And when you're asked in this class to compute a derivative using the limit definition of the derivative, this is the limit you will be computing. So let's see an example. All right, so example 1 says, for the function f of x equals 3x squared minus 4x plus 1, find the derivative of f at 2. In other words, find f prime of 2. So we first need to set up that difference quotient. So we're going to compute the limit as h goes to 0 of f of x plus h minus f of x all over h. So for us, f of x is 3x squared minus 4x plus 1. So we need to input into our function x plus h for this first term, and then input x for our next term. So first, let's compute f of x plus h. So for us, that would be 3 times x plus h squared minus 4 times x plus h plus 1. Then we're going to subtract f of x. So it's important to use a lot of parentheses here because we're going to subtract all of f of x, not just the first term of f of x. So I'm going to set up my parentheses here. And then inside here, I'm going to put in what f of x is. So for us, f of x is 3x squared minus 4x plus 1. So again, that's why we see that since we're subtracting that f of x, it's really important to keep all of the terms there in parentheses. All right, so that's our numerator, and then we're going to have all over h. And I forgot to write the limit as h goes to 0 is what we're computing. So at this point, now we just need to simplify. So what I'm going to do is bring that negative into each term, multiply out this squared, and go from there. So I have 3 times, so x plus h squared. I'm just going to write that on the side so we don't, so we're careful of what's happening when we square that binomial. So we get x plus h times x plus h. So that just becomes x squared plus xh plus xh plus h squared, which is just x squared plus 2xh plus h squared. So I'm going to plug that in here. 3 times x squared plus 2xh plus h squared. Then I'm going to subtract 4x plus h. So I'm going to bring that negative 4x, or bring that negative 4 into each term. So I get negative 4x, negative 4h. Then I have plus 1. It's important to give yourself a lot of room here because we're going to need it. So now I'm going to bring that negative into each term in that second part of my subtraction or my difference here. So then I get negative 3x squared plus 4x minus 1 all over h. All right, so let's continue. So now what I can do is expand this 3 times x squared plus 2xh plus h squared, just so that we have, oops, here we go, just so we have all of our terms together as a sum and difference. So I'll just continue here. So this becomes the limit as h goes to 0 of 3x squared plus 3 times 2 is 6xh plus 3h squared minus 4x minus 4h plus 1 minus 3x squared plus 4x minus 1 all over h. So now we can just combine like terms. So take a moment, pause the video, and see if you can simplify that numerator on your own first, and then we'll continue together. So did a lot of things cancel? Awesome, I hope so. So one thing you'll notice is that we have a 3x squared term and a minus 3x squared term. So those two terms just go away or cancel. Then we see that we have a negative 4x term and a 4x term. So those two terms also cancel. And you'll notice that we also have a +1 and a -1. So those two terms cancel. So let's collect what we have so far. So what we have left is a 6xh, 3h squared, negative 4h on the numerator. 6xh plus 3h squared minus 4h all over h. So now what do we notice about the numerator? There's an h in each term. So what we can do is factor that h out of each term. So I can write h on the outside times 6x plus 3h minus 4 all over h. And now what we notice is that h's cancel from the numerator and denominator. So what we're left with is just the limit as h goes to 0 of 6x plus 3h minus 4. So now to compute the limit, there's no problem with plugging in h equals 0 because this is a continuous function of h. So we just get 6x plus 3 times 0 minus 4. I've almost ran out of room, so I'll write it down here. 6x plus 3 times 0 minus 4. So 3 times 0 just becomes 0, and we get 6x minus 4. So now we can just take a step back and look at what we've been able to complete. And what you'll notice is that we computed from the beginning this limit, we computed f prime of x. So we actually computed the derivative of our function at any point x. And that derivative, what we found was f prime of x, after we did all of this beautiful work with the limit, is equal to 6x minus 4. So for us, we were just concerned about f prime of 2. So what we can do is plug in 2 for x here to find the derivative of our curve at x equals 2. So we plug in x equals 2 and we get 6 times 2 is 12 minus 4, which is 8. Awesome. Great work, everyone.